So one more area. This time we're trying to find the area inside this small loop. That's that area right there. So what do? There's nothing to memorize, nothing to do, just common sense. We slice it up into infinite many of these little tiny sectors. Now we agreed last time that every one of these sectors would have area that's equal to, if this is d theta, this tiny little angle, and this is r, be r squared over 2 d theta. And we explained why in the previous example. So therefore, in this case, we'd have that the small little area is equal to r squared. That would be 3 plus 7 times cosine theta squared all over 2 times d theta. And what we'd like to do is we would like to add all of these up. And observe here that we need theta limits, so I need to know what is that angle and what is that angle. Okay, to figure out what those angles should be, maybe a little bit more straight. To figure out what those angles should be, we do a little math here. The key feature when this little bubble stops and it starts, the key feature is that r comes to 0. R comes to 0. That's when you know bubbles are, or these loops are coming to the end or to the beginning. So r is equal to 0, and we also know that r is equal to 3 plus 7 cosine theta. Therefore 0 is equal to 3 plus 7 cosine theta. That would give me that cosine theta is equal to negative 3 over 7. So I make a little chart here. I will make a graph of the sine curve, and I'll make it in red. Sorry, the cosine curve goes like this. Got infinite many of these little hills, and of course this guy right here, that right there, that number negative 3 over 7 is right around here. So therefore the solution to this would be, that's the solution. Let's go with red on the solutions. No, let's go with yellow on the solutions. That's a solution, that's a solution, that's a solution, that's a solution, and there's infinite many of those. The calculator is good enough to give you the first one usually. So the first one, you would go to some calculator and say, what is the cosine theta of negative 3 over 7? Let's see if we can do that live. So we pull up the calculator here and we tell it to solve. Hey, can you solve right here? I'm looking for the angle where cosine of it is equal to negative 3 all over 7.0. So it looks like the angle, it's giving me two possible angles at least, 115 and negative 115. It's plus some change, but forget about the change. So this guy is telling me that this is about 117. Right? No, 115. I was just kidding. So here we go. This was 115. So that's 115, and there was another one at negative 115, and you got to figure out this one. To figure out this one, what we could do is we could use the symmetry of the graph. This point right here is 360 because it's one complete cycle for sine, for cosine. And since this distance right here, the distance right here is 115. The distance from here to here is 115. Therefore, this distance is 115. So if I've got 360 and I take away 115, that would get me to the next angle right here, which would be about 245, I reckon. 245, roughly speaking, degrees. And so on and so forth. To get this one, you'd go to the 360 and you would add your 115. So that one right there, you've got 360 plus 115, 475, roughly speaking, etc., etc. I don't need to find all of them. I just need to make sense of this. This angle, either it's 60 or it's 240, one of those, close to it. So I'm thinking that it's probably 245. Okay, so 245, and this one right here is probably either 300 or 100 and something. I don't know if depending on where the r is negative or positive. So this angle right here is I'm going to go with 115 degrees. So when cosine was 0, you were over here. By just thinking, when cosine is 0, that's 1, that's 10. So you're over here at 0. Theta is equal to 0. Theta is equal to 115. And when theta is equal to 115, immediately at that point you start tracing the inner bubble. And you stop when theta is equal to 240. 245 actually, roughly speaking. That traces the inner bubble inside. Okay? At 0 you started tracing here. At 90 you're tracing here. At 115 you come home to the 0, and then you start tracing the inner bubble all the way till you get to 245. That tells me that I want my limits to be from 115 degrees to 245 degrees. It's approximate because I rounded off. Remember on the calculator there's some crazy number here. Very boring number, so I just run it off. You could do it better when you have to do it for work, not for explaining purposes. Alright, so here we go. So now we've got to calculate this integral, and we'll carry on the calculation over here, and we shall do it in green. So this will be the integral from 115 degrees to 245 degrees. And we're doing, I could pull out that 1/2. This becomes 9 plus 21. That becomes 22 cosine theta. I'm foiling this stuff. Plus 49 times cosine squared theta. All that times d theta. That would become 1/2 times 9 plus 22 cosine theta plus 49 over 2 times 1/2 plus 49 over 2 times 1/2 times cosine of 2 theta. That's because of the same identity that helps you change this one into 1/2 plus 1/2 cosine of 2 theta. Famous identity from trig. Alright, that gets me to this spot right here. And now what? Now we are ready to integrate. So this becomes 1/2 times, this is 49 over 4, and this one is 9. So that becomes 36 plus 49. That becomes 85 over 4. That's putting this one and this one together, and that's times a theta plus 22 sine of theta. I just integrated that. Third of sine is cosine, so we're okay there. This one's already there with that one. This becomes 49 over 4 times sine of 2 theta, and of course I've got to do a 1/2 here to make up for the angle there. And all that is being evaluated from 245 degrees to 115 degrees. And actually you should change this to radians because you want area. So we need to change these ones over here to radians, which is pretty easy to do since we already have the calculator over here. All I got to do is change these ones to radians, and we do that just by taking away the conversion. And so we get 2 point, this one was 2.0 radians. So let's write it down so I don't forget. 2.40 radians. And the other one, of course, would be, so the other one, so we can change back to radians by taking away the degrees here. That gives us this value right here. Let me erase some of these just for fun. Let's go with the radians. Maybe it was a better idea to begin with. So this is 2 pi. The first one you can get with a calculator. This is about 2.0 radians. It's actually 2.013, whatever. To get that one, I would go all the way to the end, which is 2 pi, and then come back that many degrees. So I would do a little calculation here. Maybe do 2 times pi, and then take away 2.013 151.371. And of course this one gives me that the correct radiance here is about 4.27. So that gets us to here 2.7. So this is the same thing as going from, wow, I keep doing that, 2.0 all the way to 4.27 radians. So this becomes 1/2 times 85/4 times 4.27 plus 22 times sine of 4.27, we're in radians now, plus 49/4 times 1/2 times sine of twice 4.27, all that minus, of course, 85/4 times 2.0 plus 22, this is minus the whole thing, 22 times sine of 2.0 plus 49/4 times 1/2 sine of 2 times 2.0. Alright, crank that out and we will have the exact area inside the inner loop. Nice, huh? Once we found the area inside the inner loop, what do you think would be a good idea to do next? I'm thinking we should find the outer loop next. So stick around, we'll find the outer loop area.